5.4 Hearing from Vibration to Sound. Audition, or the sense of hearing, results when sound waves are collected in the outer ear, amplified in the middle ear, and transduced or transformed into neural messages in the inner ear. Sound waves are the physical stimuli that produce the sensory experience of sound. Loudness is determined by the intensity or amplitude of a sound wave and is measured in units called decibels. Pitch, the relative highness or lowness of a sound, is determined by the frequency of a sound wave, which is the rate of vibration or the number of sound waves per second. Frequency is measured into units called hertz, which refers to the number of wave peaks per second. Timbre, the distinctive quality of a sound, is determined by the complexity of the sound wave. How we hear, the path of sound. The outer ear includes the pinna, the ear canal, and the eardrum. The pinna is that oddly shaped flap of skin and cartilage that's attached to each side of your head. Its primary role is to catch sound waves and funnel them into the ear canal. The eardrum, which separates the outer ear from the middle ear, is a tightly stretched membrane at the end of the ear canal that vibrates when hit by sound waves. The middle ear amplifies the vibrations of the eardrum. It consists of three small bones, the hammer, the anvil, and the stirrup, so named because of their shapes. Each bone sets the next bone in motion. The innermost bone, the stirrup, transmits the amplified vibration to the oval window. If the tiny bones of the middle ear are damaged or become brittle, as in old age, conduction deafness may result. Like the eardrum, the oval window is a membrane, but it is many times smaller than the eardrum, and it separates the middle ear from the inner ear. The inner ear is the part of the ear where sound is transduced into neural impulses. It consists of the cochlea and the semicircular canals. The cochlea is the fluid-filled tube that is coiled into a spiral. The fluid in the cochlea ripples in response to vibrations from the oval window. The vibrations from the rippling fluid are transmitted to the basilar membrane. The basilar membrane runs the length of the cochlea and is embedded with hair cells, the sensory receptors for sound. Hair cells have tiny projecting fibers. If damaged, the result can be nerve deafness, which cannot be helped by a hearing aid. Transduction finally occurs. As the hair cells bend, they stimulate the cells of the auditory nerve, which carries the neural information to the thalamus and the auditory cortex in the brain.